In the previous lesson, we have seen how to create a MongoDB Atlas account and how to connect to the MongoDB database from the application using Mongoose.js library. In this lesson, we will see how to interact with the database to insert the data and read the data from the database. Before doing that, let's first remove the unwanted code. Let's remove the public folder as it was only learning purpose and it is not needed in the final code. We also don't need the not found page, so we can delete that also. We don't need to change anything in db.js file. In .env file, you need to remember to add database name after last slash. So, if you click on your project and click on Connect button, now select Connect your application option. You can see the database connection URL, but there is nothing written after the .net slash. So, you should put your database name after the slash. Let's say Todo's app. If that database does not exist, it will be created, otherwise already created will be used. Now, we can restart the application again. So whenever you change .env file, always make sure to restart the application. Now, let's remove the unwanted code from index.js file also. Before writing code for MongoDB, you should know that MongoDB is a NoSQL database which stores the data in JSON-like format. If you have worked with SQL databases like MySQL, PostgreSQL, you might know that they have tables and columns. In MongoDB, we don't have concept of table, instead we call it a collection. So table in SQL is same as collection in MongoDB. And row in SQL table we call record, but in MongoDB, we call it a document. So I have created a models folder and inside it, we will create a structure for our first collection. We can call the file todo.js. Now, let's first import the Mongoose library. Then we can create a to-do model. It's a convention to start the model name with capital letter. And we can call mongoose.model method. And as a first parameter we need to give name for the collection we will be creating. Let's call it to-do itself. Again, make sure it's written in capital first letter. And for the second parameter of model method, we need to provide the schema or structure of the collection, which is a table we will be creating. So let's name it to-do schema and we use new mongoose.schema constructor function. S is capital again. And we need to pass an object where we specify the data type and fields of that collection or table. Let's say for the to-do collection, we have a title field of type string. All the types we specify have uppercase first letter. Also, let's make the title field as required field so the value will never be empty. Let's also add a status field with type string. And we can define the values for the status field as an object. In that object, we can have not started, in progress, and completed status properties. We will make the status field as an optional field using required false property. And we will set default value of not started for the status. So user don't have to provide the value for status field, as the default will be not started. Here we can say statuses.not started. For title, we can also add a trim property with value of true. So if user enters some spaces at the beginning or after the title, those spaces will be removed while saving the data. So if we go to Mongoose.js website, we can see all the available properties we can specify while defining the model structure. If you click on Schemas menu, you can see all properties we can assign. You can directly specify the data type if you don't have extra properties. You can also see a list of data types you can specify as shown here. Now, we have created this schema and so we can pass it as a second argument to the model method. Now, we can export this to-do model using module.exports. So we can use this model in any other file. Let's import the file in index.js file. And we can store it in a variable with name to-do. And because it's a default export, we're not using curly brackets while importing like this. Also, as it's a model, always use the capital first letter as shown here, which is a good practice to have. Now, let's insert some data in the to-dos collection. For that, we need to create an object for to-do model using new operator. As you can see, the to-do model requires a title and optional status field. So I will provide a title of first to-do. And I will not provide the status field, because it's not required to be provided. And now, to save this to-do to database, we need to call the save method on that to-do instance. As we have added this code in index.js file, once we save the file, the NodeMon will restart and the data will be saved into the database. So let me click on the refresh button. As you can see, we have to-dos app database and inside that, we have a collection with name to-dos. So the to-dos app is the database name we have given. And in that database, we have created to-dos model. So when we give singular name for model, Mongoose automatically adds an S to make it plural. And we have a single document which we just added in the database, with the title and status fields. Even though we have not provided status while saving the document, you can see a default value of not started is added. We also added trim property for the title, so let's verify that also. So, I will add a new document with another title and I will add some extra spaces at the end and beginning also. And I will also provide a status this time with value of completed. Now, once the NodeMon restarts and database is connected, this new to-do will be added in the database. As you can see now, the second to-do is added and it does not contain the spaces because those are removed because of the trim property. Also, if you see, we have _ID property which is a globally unique identifier of type object ID. So for each new record _ID is automatically created by MongoDB. Now, I will comment out this code and I will add to-dos root to get all the added to-dos. app.get/to-dos. And here, I will use to-do.find method. You can see there are a lot of methods you can use to find data. And I will pass an empty object to find method to find all the documents from the to-do collection. The find method returns a promise with the array of found elements. So we can attach .then handler to handle to success case. Here we will return back the to-do using response.send method. And we will add a cache handler to handle the error, if any. Now, if we access the /todos root, we should get the list of added to-dos. So whatever we have inserted is returned when we access /todos root. If you check the _ID, in database it's showing as object ID, and in the API, we're getting a string. Database shows it as object ID to explicitly specify that it's of object ID type. So if I search for MongoDB object ID, you will get more information about it. As you can see, the generated ID is a 12-byte ID. The first 4 bytes of those 12 bytes are timestamped, which will always be unique. Next 5 byte is randomly generated value, and the last 3 bytes is an incrementing counter, which is also a random value. The object ID is a globally unique identifier, so you will never get the same object ID anywhere else in any of the databases. It's always unique across all the MongoDB databases in the world, as it also includes a timestamp value which is always unique at every millisecond. So this object ID is a unique ID automatically generated by MongoDB for every document in your collection. For inserting the data in the collection, we have manually added at the start of the script. However, you should have a route for specifically adding and getting the data. And all that code, we have added directly in the index.js file. But the number of routes increases, your code in index.js also increases, and it becomes difficult to manage and understand the related code. So to handle that, we can create a new folder with name controllers where we add the core logic of the code. We will also create routes folder where we put only the routes. So this route, we can move into the routes folder. Let's create a todo.js file. And in this file, we can move that route related code. Now, we can import the Express module. And using Express, we can create a router. Router equal to express.router. So Express provides a router using which we can create different routes. Now, instead of app, I will use that router, and we will export that router from the file as a default export. So, now you can set up multiple routes related to this to-do in a single file attached to that router. Let's say a to-dos route with post request to add a new to-do. And we just need to export the router. For now, I will remove the code from post route. And the actual handler code we will move inside the controller folder. So let's create todo.js inside controllers folder. And here, I will move that handler code. So I will cut this code. And I can create const get to-dos, and I will paste the copied code here. Now, this get to-dos I can export as a named export, because I can have multiple handlers in a single file, so we export it in an object. And now, here I can import that get to-dos handler function. As you can see, we're importing from the controllers folder and it's a named import. Now, I will remove this handler code, and in the to-dos controller, I will add another handler function with name add to-do. And I will export this function also. Now this add to-do, I can import in the routes file. So this is how you can structure your code. And only route-specific information you will have in the routes folder, and actual handler code in the controllers folder. Now, I can remove this code, and let's import those created routes. Require /routes and to-do. And we can store it in variable with name to-do routes. To use these routes, we need to add them as middleware using app.use method. This is how we can separate out routes code from index.js file. Now, we don't need this to-do import. Instead, we need to import that in the to-do controller. And now, as you can see, there is no error in console. And if we refresh the page, it still works without any issue. So with this structured code, if we have profile.js file containing profile-related routes, in this file, we will have /profile get and post routes. And this profile route, you can import in index.js file. Call it profile routes. And we can add another app.use for the profile routes. So this is how we can separate out different routes related to profile and to-dos. This was just to give an example, but we don't need profile routes right now, so I will delete that code. As you can see, we have /todos route, but whenever we create REST APIs, it's always better to serve the API routes starting with /API. For example, /API/todos. Currently, we don't have any such route, so we're getting an error. So to make it work, we can add /API/todos here. So whenever we access /API/todos, we go to the todos routes, and we don't need to mention /todos here again, so we will remove it. And if we refresh the page, you can see there is no error and we correctly get the required data. And if you want to have profile routes, then you can write it like /API/profile and specify the corresponding routes. So always make sure to start your APIs with /API route, which is a good practice to have. In the next lesson, we will see how to create POST request APIs to accept data from the user and insert it into the database. You will also learn how to use async await instead of .then and .catch to write clean code. You will also learn how to do proper error message handling for different scenarios. So see you in the next lesson. If you found this video useful, do like the video and subscribe to the channel.